Okay, now using the knowledge about friction, so we have to internalize uh, three ways to calculate the dynamic of an object. So first, if the particle is in equilibrium, always remember that the summation of forces is equal to zero. So we have to use Newton's first law of motion or the law of inertia. So particle in equilibrium means that the particle is at rest or the object is moving at constant velocity. Okay? And second one, if the particle is not in equilibrium, use the second law of motion or the law of acceleration. So ito yung particle nga nag-accelerate na siya. Okay? This is to completely describe the dynamics of an object. So using these two laws of motion, we can now describe the dynamics of an object. So remember that if you have to sum all the forces acting on object, that is equal to mass times acceleration. Okay, if your object is not in equilibrium. But if your object is at rest or moving in a horizontal or inclined surface with friction, so you have to take note kung unsa ba siya nga friction. Is it static or is it kinetic? Okay? So you already knew that one, the difference between static at saka kinetic. However, may mga problems nga ibutang dito so nga the coefficient of static, the coefficient of kinetic. So you know beforehand before digging in or going to war or going to the equation. So you will already know beforehand nga static or kinetic ba ang type of friction on the system. Okay? So let's answer or let's apply those three rules in solving the dynamics of an object. Okay, so first, the object weighs 15 Newton and is supported by a cord. Find the tension in the cord. Okay, so we have to find the tension. So first, we have to take note kung ano yung object of interest natin. So ang object of interest is actually our 15 Newton object. Okay, so we have that one. So we have to put an object like a point because of particle model. So what are the forces interacting on the 15 Newton object? So we have the tension because it is connected to a cord. So this is the tension. Okay, what else? We have the weight of the object. Gahang na siya sa ceiling. So wala siya surface. So weight lang yung tension ang naa sa atua. Okay? So at this point, I have to kanang para fix ta tanan sa atuang coordinate system. So if naa ko'y upward, positive na siya nga force. If downward siya, negative nga force. To the right nga force, positive. To the left, negative nga force. Okay, tana ha? So this is actually our y, this is our x. So ana lang. Okay? So basically yung forces natin is along y lang. So meaning kung along y lang siya, so we have to take note that summation of forces along x and summation of forces along y. Of course, summation of forces along x is still equal to 0 kasi at rest yung object natin. Meaning wala siya nag-move ba? Okay? Or wala siya nag-accelerate, I mean. So this is actually no information. We cannot have an information because wala may forces along x. How about the forces along y? So since wala man nag-move ang yung object is at rest, so meaning the forces along y, that is the tension at saka weight, is actually equal to 0. And then add all of the forces based on our coordinate system. So kung upward nga force, that is positive t. Kasi upward man siya. How about yung weight natin? This going downward. So that is minus the weight, which is equal to 0. So our problem states that we have to find the tension in the cord. So using this equation, we can find the tension. So T is just equal to the weight of an object is equal to 50 Newton. Then therefore, the tension in the cord is 50 Newton. Okay lang, 50 Newtons. How about number 2? Okay, so number 2, A 5 kilogram object placed on a frictionless horizontal table, okay, frictionless na, is connected to a string that passes over a pulley and then is fastened to a hanging 9 kilogram object. So our pulley is assuming nga wala siya friction, meaning frictionless pulley natin. Okay? So draw an FBD of both objects and find the acceleration of the two objects and the tension in the string. So guys says, you have to take note na if ever nga wala gani siya ingon nga draw an FBD, you have to draw gid ha, because I will put an points man if mag-draw kayo ng FBD. So even though wala gibutang gi-state sa problem, so you have to draw gyud, that is default. Okay? So we have to find first the FBD of two objects. So that is the 9 kilogram at saka ni 5 kilogram. Okay? So sa 5 kilogram muna, so ano yung forces ni 5 kilogram? So we have here, since naman siya sa horizontal table, so what are the forces? So we have the normal force, we have the weight of the object, weight of the 5 kilogram. What else? We have the tension because it is connected to the tension which is going here. The tension. What else? Wala na. Okay, I think wala na. Kaya ingon man siya nga frictionless. So wala ni other forces here. Yeah, so that is the free body diagram of your 5 kilogram. Okay, so the tension here, I remember nga if ever gani nga naay tension nga same lang gyapon og rope ang gigamit, as you can see here, same na silang tension. Okay? So how about for the 9 kilogram? This is the 5 kilogram. How about the 9 kilogram ng FBD? 9 kilogram. So how much is that? So we have here, so how much is the 9 kilogram? Okay, how much is the 9 kilogram? So the 9 kilogram is actually is this one, 'di ba? Naghang siya. So since hanging man siya, wala siya normal force, pero naa siya tension because it is connected to the same rope or cord as the 5 kilogram, 'di ba? So we can put our 9 kilogram by a point, and then next is we have to you know, tanaw na to ang ubang mga forces. So we have the tension, same tension gyapon kay again they are on the same chord man silang duha, so same gyapon tension. The next, sa pa nga tension, we have the sa pa nga forces, we have the weight of the 9 kilogram, diba? So yeah, I think that's all naman. Okay, so we have to find the acceleration of the two objects and tension in the string. So we have to take note kung asa siya ni accelerate o asa siya ni at rest, meaning that not all of the forces man good are equal to 0, na po equal to MA. Remember that. Okay? So we have to separately find the summation of forces along X and the summation of forces along Y for two objects. So we have summation of forces along X of the 5 kilograms, I will just put 5, is equal to, how much is that? So is it equal to 0 or is it moving or is it accelerating? So take note of the object. So basically mas bugat man si 9 kg kani 5 kg, di ba? So mo-accelerate imong object paana. This is the acceleration, and this is also the acceleration of your 9 kg. So basically they are on the same acceleration kasi they are connected at the same chord. Okay? Connected lang siya. So remember pud na imuhang string dili is not stretchable, kasi kung stretchable siya lahi man yang acceleration na dayon, di ba? So dapat dili siya stretchable, dapat fix lang yang length para same sila og acceleration. Okay? So the forces, so we have to also indicate which is what is the motion of the object of the 5 kilogram. So that is in separate na arrow. Nganong i-separate man? Because acceleration or the ma is not a force, but it's just an effect. That is why we have to separate that one to the object. This is just to indicate the direction of motion of the object. Okay, not a force. Okay? So ibutang lang nimo ang forces if force siya on the object of interest. Okay? So the force exerted on 5 kilogram along x is we have mass of 5 kilogram times the acceleration. So they have the same acceleration, assuming that your string is a non-stretchable. Okay? So what are the how about your summation of forces along y for 5 kilogram? So that is equal to, nag-move ba siya sa y? Wala, 'di ba? Sa x naman gamove yung acceleration. So meaning that along y your forces is equal to 0 kay wa may acceleration along y. Okay? So mao na siya. That is the equation for for the forces of 5 kilogram. How about the forces for the FBD? So unsa man siya forces? Okay. So unsa may forces niya? So we have here we have the summation of forces along x for 9 kilogram, which is just equal to the mass. Okay. Wala tayong makukuha ang information kasi all of the forces is along y ra. So meaning that is equal to 0 pero no information. Okay, excuse me. How about for the y? So again, accelerate siya along y. So this is our coordinate system along y. So summation of forces along y for 9 kilogram is equal to mass times acceleration. Kasi na-accelerate man siya along y. Okay? So ana lang. So we have to use these equations para makuha na to ang tension in the string at saka acceleration of the two objects which are theoretically in the same sila og acceleration. So first, we have to identify the forces and what are their conventional signs. So for the summation of forces along x sa 5 kg, so we have the tension which is positive and that is equal to mass of 5 times acceleration. Okay, usa man ang iyahang forces along x, si tension naman, and that is to the right, pajud, so meaning positive. How about the summation of forces along y sa 5? So we have the normal force, then we have also positive, that is upward, minus the weight of the 5 kg which is downward, so that is why negative, that is equal to 0. So this could be our equation 1, this could be our equation 2. Okay? How about for this one? So ayun na siya kapila kay wa man ta information na makuhaan na. But we can use this equation para makita nato ang information or makita nato ang acceleration at saka tension. Okay, so we have here the t is going up, so t minus the weight of the 9 kg object, then we have the mass of the 9 times 8. Okay, so this is our equation 3. So how to find the acceleration at tension? So remember, yung tension mo here from equation 1 is equal to m5a. So we can, since yung t mo is equal to t here, so we can substitute the value of t to equation 3. So we have substitute 1, 2, 3. So we have here m5a minus the weight of the 9 kg object, which is equal to mass of 9, tapos we have the acceleration, then we have to find the acceleration, diba? So we have to put this one here, so we have m5a minus m9a is equal to the weight of the 9 kilogram object. Okay, then we can put A outside, so we have A times m5 minus m9, that is equal to the weight of the 9 kilogram object, that is equal to m9 times g. Okay, so divide both sides by m5 minus m9, so we have A is equal to m9 g divided by m5 minus m9. Okay, so we have this equation. So what is the mass of the 9? Mass of the 9? So always remember that you also have to take note kung yung acceleration mo is positive or negative. Depende sa direction ng acceleration mo. So I forgot that your acceleration of your x here is positive sa imuhang 5 kg kasi to the right man siya, di ba? So wala tayo mabutang dari. Pero here kasi since your acceleration mo is downward, then supposed to be yung acceleration mo for Fy9 is actually negative m9a. So sorry about that. So we have negative here, then we have negative here. So that is why if we put here to dire, yung mo siyang positive, and then we have positive, and then we have positive. So sorry about that, positive dapat siya. Okay, kasi you have to take note about the direction also of the acceleration. Okay, so simplify. So we have 9 kilogram times 9.8 meters per second squared divided by the mass of 5 is 5 kilogram plus 9, which is equal to, how much is that? So that is equal to 6.3. So the acceleration of two objects is 6.3 meters per second squared. Okay? So we are done with acceleration. So based on the equation 1, we can now find tension, di ba? So from 1, since T is equal to mass of 5 times acceleration, so we have here 5 kilograms times the acceleration, 6.3. How much is that? So we have 5 times 6.3. So that is equal to 31.5 Newton. Therefore, kaningon man siya nga the acceleration of the two objects, so you have to also to take note about their direction, okay? So acceleration of 5 kilogram is equal to 6.3 meters per second squared to the right. You have to put to the right to specify the direction. Then the acceleration of the 9 kilogram is still equal to 6.3 meters per second squared downward. And then the tension is equal to 31.5 Newton. Ano lang. Or you can write the acceleration of 5 kilogram as equal to positive 6.3 meters per second squared, meaning that your acceleration is positive to the right. Then acceleration of the 9 kilogram is equal to negative 6.3 meters per second squared, meaning it is downward. Okay? So pwede na po na siya. Pwede na ko siya accept. So this is our answer. Okay? So yeah. Mo na siya ang duha ka. How about if natay tulo ka objects? How to find the acceleration at saka tension? So yung object mo is si 4 kg, si 1 kg, tsaka si 2 kg. Okay, so I have to put it here. So we have to I will just read the problem, okay? So 3 objects are connected on the table as shown. The table has friction na, which is coefficient of kinetic friction of 0.35. Draw a free body diagram of each of the objects and determine the acceleration of each object and determine the tension of two chords. Okay, So tension of two chords, so meaning lahi ang tension diri og diri. Kay ngano gani? Lahi-lahi naman ang connection sa rope. Kani siya is connected to 4 at saka 1. Kani siyang rope is connected sa 2 at saka 1. So always take note nga yung pulley here is frictionless. Meaning hindi siya maka-affect sa ating acceleration. And then yung cord natin is actually not stretchable. Para yung acceleration niya are all equal all throughout sa dynamics. Okay? So if you take note of the kung imong buyan ang object or imong buyan si 4 kg, what will happen to the object? So basically, i-drag niya tanan ang mga masses padung ni 4 kg. Meaning, ang acceleration ni 1 kg is going in that direction. This is the acceleration of 1 kg. The acceleration of 2 kg is going upward. This is the acceleration. And the acceleration of 4 is going downward. Kasi i-grab man siya. Diba? So yeah, mao to siya ang acceleration. So we have to find the acceleration at saka tension of two chords. So how to find that one? So even though the tension are different for the connection of the three objects, you have to take note that the acceleration is still constant all throughout. Okay, kasi yung again, hindi siya stretchable yung chord natin. So unless na lang kung may isang stretchable, so we have to take note of different acceleration. But here, yung acceleration lang is nakadepende if yung chord mo is stretchable or not. It doesn't matter kung ano yung mass ng object na nag-connect sa chord. Okay? So we have to find the free body diagram first. So I will just put it here. So diba atong object is ana table dari, na ako'y pulley, kuntang pulley diha. So sorry sa akong drawing. So na ako'y 1 kg dari, then na ako'y 2 kg, then na ako'y 4 kg. So I will just put the acceleration of 1 here, acceleration of 4 here, and acceleration of 2. Then find FBD. So FBD of your 1, mass 1, I will just put 1. Okay, so mass of 1 as represented by a point. So what are the forces acting on the mass 1? So naman siya sa surface, so na siya normal force. Napod siya weight, of course, weight of the 1. So I will just put 1. The next is na siya friction. Okay, because ngano gani ang friction is opposing the acceleration or the motion of the object going in this direction. Friction. What else? We also have two tension. So tension connected to 1 to 4 and the tension connected by 1 to 2. So we can put this one as tension 1 to 2 at saka tension 1 to 4. Okay? So the tension is pulling here, I think. So we have here the tension of 1 to 4. Then we have here the tension of 1 to 2. Okay, so na siya duha ka tension. So you have to overlap lang kasi forces man siya on the mass 1. Okay, just like what I said sa sample problem about FBD. Then you have to put the acceleration just here above, separate from the free body diagram because it is not a force. Okay, so again, I think that is correct. The pulling force. Okay. So how about for FBD for 4 kg? So again, we can represent the 4 kg block as a point. Then what are the forces? So just the tension of 1 to 4, the cord connected to the 1 and 4 kg, and then also the weight of the 4 kg, and then the acceleration which must be separated from the free body diagram. Okay, so ano na siya kadali? How about the free body diagram for your 2 kilograms? So we can represent this one by a point. And then what are the forces? So still we have the tension But this one is now tension 1 to 2, not anymore tension 1, 4. Okay, because this tension is not the same as the tension here. And then the weight, of course, of the 2 kilogram object. Then the acceleration is we have to separate again from the free body diagram, since acceleration or MA is not a force. Okay? So yung acceleration niya sa 1 is negative, so you have to take note of that. Acceleration of 4 is still negative, kay downward. And the acceleration of 2 is upward, so this is positive. So we have to put all together the equation. Okay, equation of motion for FBD 1, 2, at saka ni 4 kilogram. So for 1 kilogram, okay, so for 1 kilogram, we have to sum all the forces. So we have summation of forces along x of the 1 kilogram is equal to, okay, since along x, yung acceleration natin, nag-move man siya along x. So meaning, yung body along x is not in equilibrium. So we have mass of the 1 kilogram times the acceleration. Okay, meron siyang net force. How about along y? So along y, wala siya nag-move along y. So therefore, your acceleration, your net force is equal to 0. Okay, in equilibrium siya along y. How about for 4 kilogram? Ano yung mga forces along x at saka y? So forces along x is basically equal to 0, pero wala tayong makukuha na information. Okay, so basically useless ang useless ni siya nga equation. Then how about the summation of forces along y for 4 kilogram? Okay, so since nag-accelerate man siya along y, so we have to take note. Okay, so I forgot that your acceleration for 1 kilogram is negative, so I just have to put negative here. And how about for this one? So still negative, but your mass is now equal to 4, so M4A. Okay, so how about for 2 kilograms? So 2 kilograms is you have to sum all the forces along x tsaka y. Same as your 2 kilogram, your 4 kilogram, we cannot have an information along x kasi walang forces man along x. So this is no info and this is useless. Okay? How about for forces along y? So for the forces along y, for 4 kg, this is 2, not 4. For 2 kilograms is equal to positive na kasi positive yung acceleration natin. So positive m2a. So meron siyang acceleration along y. Okay? So you have to take note kung asa directed ang atong acceleration ha. Kung directed siya sa along y, meaning ang net force niya is nasa along y. Pero kung directed siya sa along x, ang net force niya is nasa along x. Okay, see the difference? Okay? So simplifying, so we have to take a note of the forces along x in 1 kilogram. So the T14 is negative and the T12 and saka FK are all positive. So we have T12, kasi base ito sa coordinate system natin ha, na kung to the right, positive, to the left, negative. So T12 plus the friction force, kinetic friction, kasi we are given that yung static friction natin is coefficient of kinetic friction is 0.350. Okay? So next is minus T14 and that is equal to negative M1A. So this could be our equation number 1. Okay, how about for summation of forces along y? So summation of forces along y for 1 kilogram, we just have to N, the normal force, minus the weight of the 1 is equal to 0. So this could be our equation number 2. Then walang makukuha natin dito. So you cannot, ayaw rin na siya appeal sa atong equation. Okay? So just proceed to forces along y. So we have here, what are the forces along y? So based on our coordinate system, that is T14, minus the weight of the 4 kilogram, that is equal to negative 4a. Okay? So these are equation number 3. Same lang din sa 2 kilogram. So we cannot use this information. Okay? So we have here, okay? So we cannot use this. Okay, sorry. So we cannot use this information. Okay, what is happening? Okay, so what? Hindi na ako makaride. Okay. So wait lang. I just have to, what is happening? Okay. The load. Sorry. So yung no info, you just have to scratch that out. Okay? So scratch this out.